Welcome to this explainer. Today, we're diving into a massive shift in how we maintain the infrastructure right beneath our feet. We're looking at how modern video inspection has completely revolutionized drain diagnostics. It's basically shifted an entire industry from blind speculation to cold, hard visual evidence.
I mean, think about it. How do you fix a problem that you can't even see? For decades, professionals working with buried pipes had incredibly limited tools. If a drain failed, well, it meant relying on educated guesses. You'd listen for a gurgle, measure the flow, and kind of make some really risky assumptions about what was actually happening deep underground. And we're talking about millions of dollars in municipal and private funds hinging on these blind guesses.
The contrast between that old guesswork era of trial and error and today's modern approach is honestly staggering. Instead of just guessing, technicians now get undeniable visual evidence before they ever start cutting, digging, or replacing any infrastructure. We've essentially replaced crossing our fingers with a direct high-definition feed, which, as you can imagine, saves countless hours and prevents some seriously unnecessary and expensive excavations.
Which brings us to Section 1. Seeing is believing. Now, when we talk about video inspection technology, we really need to clarify something. These aren't just basic cameras taped to a stick. We're talking about highly sophisticated systems. They use steerable camera heads to navigate really complex layouts, high lumen lighting to pierce through the muck, and advanced digital recording platforms. It gives us an undeniable, real-time look at exactly how water moves and precisely why a system is failing. It's totally changing the economics of infrastructure repair.
So, the core philosophy of this massive shift is moving from simply a problem found to a problem understood. A slow drain used to be a complete mystery, right? Like, is it grease, mineral scale, a damaged joint? Now, all that uncertainty just vanishes. We instantly understand the exact nature, size, and location of the defect. It transforms what used to be a stressful guessing game into a highly targeted engineering task.
Moving right along to Section 2, uncovering drain disasters. When technicians actually send these cameras down the line, the technology immediately helps them differentiate between, a minor nuisance and a total disaster. They can instantly know if they're dealing with just a simple temporary grease obstruction, or if they're looking at severe structural conditions that are literally on the verge of complete failure. Having this absolute visual confirmation lets crews match their approach to the reality on the ground. That drastically reduces unnecessary work and prioritizes the most urgent structural threats. And when we look at the sheer variety of common diagnostic scenarios lurking underground, the value of this tech becomes incredibly obvious. Crews can instantly confirm if a clog is a soft blockage or a tightly packed wall of debris. They can see exactly how far invasive tree roots have penetrated the system. They can spot structural failures like cracks and severe corrosion that routine cleaning could never, ever fix. And crucially, they can locate offset pipes and changes in slope, which are usually the real hidden culprits behind those endlessly recurring backups. Plus, having all this data geolocated means teams can pinpoint exactly where a problem begins and ends.
Now for Section 3, smarter repairs and reporting.
What's so amazing here is how this technology radically compresses the timeline between diagnosing an issue and actually taking decisive action. Right out in the field, technicians can instantly review high-definition footage, consult with their supervisors remotely, and communicate the next steps to property owners, all without ever leaving the site. The targeted repair happens immediately, and then they generate a full, comprehensive report right from the truck. And that's standardized reporting. It's an absolute game changer. The platforms supporting these cameras generate annotated footage, precise measurements, and formal defect classifications. This geolocated data isn't just nice to have for peace of mind. It's absolutely essential for managing complex, multi-phase repairs, handling warranty discussions, and helping municipalities with their long-term infrastructure planning. Strict traceability and accountability are paramount there, and this delivers exactly that. Which leads us to our final section, Section 4, Proactive Plumbing Futures. We are actively breaking the old, highly reactive clear it now, fix it later cycle. By tracking precise structural changes across multiple inspections over time, operators can engage in genuine, proactive monitoring. So watching a microcrack expand over months or measuring progressive root growth means facility managers can actually schedule localized interventions way before a total blockage turns into a catastrophic, incredibly expensive emergency. Looking ahead at what's next for Dream Diagnostics, the evolution of these systems is incredibly promising. We can expect even sharper image clarity and way better robotic navigation through those complex pipe networks.
But beyond the hardware, the software is advancing just as fast. There's a major push towards streamlining defect identification workflows, essentially giving these systems the remarkable ability to automatically convert hours of manual footage interpretation into faster, more consistent insights and actionable maintenance work orders. It takes a historically messy job and turns it into a precise, data-driven science.
So, with technology rapidly advancing to automatically categorize defects using AI and machine learning, it begs the question, will the drains of tomorrow be able to diagnose themselves before they ever back up? It's an incredible evidence-based future for the critical infrastructure right beneath our feet. Thanks for joining me for this explainer, and keep questioning what's going on beneath the surface.